A very good afternoon, everyone. My name is Gilles Traxel from IDQ. I'm leading the EMEA sales and product management for the company, and I will be your host for this session. On behalf of Hitachi-ABB and IDQ, let me welcome you to this webinar titled Quantum Safe Power Grids. I hope that despite the COVID situation, you are all safe wherever you are on the globe. This webinar is part of a series we started a few months ago. It will be recorded. It can be rewatched anytime on our website. So just type www.idquantique.com/webinars or go to our news and events section, and don't hesitate to forward it to your colleagues. So, Hitachi-ABB and IDQ have a long-lasting co-development and partnership history, and the joint solution you will learn about today is one of the outcomes of this very fruitful collaboration. And now a quick introduction to the topic of the day. The nation's critical infrastructure provides the essential services that underpin society and serve as the backbone of the economy, security, and health. While control systems used to be standalone, advancements in remote monitoring and big data analytics means they have become more integrated with other systems, exposing them to new risks as data is in motion across larger scale networks. Action is then required to ensure current security and to prepare also upgrade paths for future technology advances, such as quantum computing. The energy and utilities market has become increasingly aware of the need for quantum-safe technology over the past couple of years. IT security teams have a tremendous responsibility to safeguard data and critical infrastructures, and we rely essentially on cryptography to uphold that responsibility. This makes robust cryptographic protection a must. Before we start, just a few words about how we will handle questions this afternoon. So we will have a Q&A session at the end of the webinar. So if you have any question, please use the questions box on the platforms. Thank you in advance. With that, let me introduce you our two speakers. We will start with Olivier Pfeiffer, Director of Finance and Critical Infrastructures, Markets at ID Quantique, and then Ruven Vleuten, Global Product Manager, Cybersecurity Solutions at Hitachi-ABB Power Grids, will take over. So I think we are all set. Up to you, Olivier.
Thank you, Gilles. Thank you for the introduction. So I wanted to start with telling you what's new in the quantum world. As Gilles mentioned, quantum is has been starting for a while. But what we believe is that the quantum decade is now, it has begun. And the living proof of that is the fact that ID Quantique, although it has worked on QRNG, quantum random number generators, for a long time, recently integrated this functionality in mobile phones, and not only with mobile phones, with the bigger brands like Samsung and Vinsmart, which really shows the end of a big cycle of development, and which symbolizes also the advancements of quantum technologies. And as a matter of fact, we see that really very comparable to the advent of the internet. And what you see here, the graph, is showing the number of hosts on the internet from the 80s to until now. And we see really the parallel with quantum technology and QKD, quantum key distribution, as being in the, just before this big wave is starting to emerge, and will, certainly come to complete fruition in the next 10 years as the quantum computer will start to appear and become more and more important in our lives. We've seen, in parallel to all of this, we've seen a very big investment from different governments, being North America, Europe, Asia has been obviously, with China, the biggest, investment so far. But Europe has, started with the flagship program, which has generated about 1 billion in investment. France and Germany also very prominent in Europe, showing that there is a real consensus on the importance of those technologies today and for the future. Just to come back a little bit to ID Quantique, this company was started about 20 years ago by 4 physicists in Geneva. Today, it is about 100 people. We're mainly focused on 2 divisions. One is quantum safe security, in what we'll discuss mostly today. The other one is quantum sensing, which has different prerogatives, and in particular working on different sensing technologies for labs and testing fibers, and also single photons detectors. We're active in a lot of verticals, government, universities, gaming, and we are also active in, obviously, very active in R&D, professional services, and are currently working with a lot of partners to integrate our technologies with different encryption companies, for example. So the quantum technologies is not only quantum computing, but it's, as I mentioned, quantum communication, quantum sensing, and quantum computing is very promising technologies that will definitely have big impact, already have some impact on some verticals like chemistry or biophysics. But the big threat of the quantum computer is also that it breaks the keys. So obviously, a lot of industries have to worry about it, but critical infrastructure and the grid applications are, obviously much more conscious about the future because they invest for a very long time. So we have to have solutions that will have a long-standing security. And for that purpose, we try to symbolize that in a graph, showing on the top with the red line how QKD will react in time. We believe it's not going to change in the level of security compared to other means of securing content or data, which are based on mathematics, obviously will diminish in time as quantum computing will evolve, but also regular computing, and that obviously everything that's based on mathematicals algorithm will lose with time, as obviously people will try to attack them more and more, and the power of the computers will also increase. Obviously, the blue line that you see at the bottom, starting in 10 years, that's sort of when we see this advent of the quantum computer. Obviously, at that time, regular encryption, which is symbolized by the blue line, will have no effect on protecting data anymore. So QKD is really the only technology that today can be proven to be safe over a long period of time, which we're looking at when we're talking about electric grids. And so the question is, when will this all happen? And Michael Mosca, who is a prominent scientist in Canada, and we call that the Mosca theorem, is really stressing the fact that not only do you have to know when the quantum computer will emerge, but we also have to be very aware of the time you'll need to migrate to those post-quantum security solutions. And especially if you have a very long time, if your data is worth a lot in a very long time, and that in that case, you would have to make sure that this data is protected already today, because you're going to have a very long migration time plus a very long life data. So the data could also be downloaded today and decrypted later. Whereas, if you have a very short time, you might be okay for a few years. But in the industry we're talking about today, I think it's very crucial to take that into account and also know your data very well. So QKD has evolved over time as well. Quantum key distribution was started with a point-to-point distribution, And we're now working on very complex topologies, going from ring topologies or forward functions that allow to have to have trusted nodes to forward the key information to longer distances. Not only distance is important, but resilience is very important. So you have to have different routes going from A to B or C that you can use if one of them is compromised. So that's something that now ID Quantique is really focusing on, is to be able to integrate in telecoms, in telecom networks, and to be able to respond in case of failure on one of the links, to reroute dynamically those keys where they have to go. Couple of use cases in the energy sector. These two are in Korea. One is KEPCO, which has basically used the ground wire of electric, underground electric distribution to carry QKD keys. And the other one is the nuclear power company in Korea, which is using that between their distribution centers to carry confidential information. So just to sum up, what we really advise is to really have a good idea of what your data is, where it is, which parts of your data is important, and to identify the very critical links in which data has to be protected in particular. And one way of doing that is to really understand the future value of the data. And if it has a value in 10 or 15 years, it really has to be acted upon now. The next step is really to make sure the source of randomness for creating the keys is perfect, and QRNG has been proven to be that. Crypto agility is something that is as important, because obviously you need to be able to have a dynamic control of the algorithm you use to protect your data, and therefore it has to be something that can be dynamically changed as the algorithms are changing and are improving. And obviously QKD on very critical links has to be implemented as well when you have very important data circulating on low level networks that require that level of security. So I will hand over to Ruben. He will discuss in more detail how this applies to the grid and to critical infrastructure, and give you more details on implementation that have been done between our companies on actual projects.
Yeah, thank you, Olivier, for the introduction. Yeah, my name is Ruben Flöter, Global Product Manager for Cybersecurity Solution at Hitachi-ABB, a new joint venture. And I want to give you a view inside our solution, what we offer for our customer, and what is our answer to the quantum safe and our answer to the upcoming threat on this quantum computer. And I also want to show you some use cases dedicated to power grids, but more in details now. Next slide. So Hitachi-ABB is a joint venture started at this year, mid of this year, 2020. The PG, the power grid, was part of the ABB group. So we have a very, very long history. You see 1891 to BBC, founded to ABB, Asia Brown Boveri, and now Hitachi-ABB Power Grid. So the power grid business unit was carved out to a joint venture between Hitachi and ABB this year. Next slide, please. So Hitachi-ABB Power Grids and overall has 36,000 employees. Inside the Hitachi Group, we have 4 business units. This is grid automation, grid integration, high voltage, and transformers. I'm from grid automation, and grid automation also includes the grid communication. And I want to introduce a solution that comes out of the grid automation business unit. Yes, we have 115 factories, over 2,000 engineers, 10 billion business volume overall. And now with Hitachi, I think we have a very, very great future also to establish such technology in the market. Next slide. Mission critical communication. Though in power grids automation, you have critical communication solution. Here are a few of them. Hardware solution. You see they have teleprotection for power application. We have wireless devices, Tropos, for example, for wireless access point. We have access and aggregation devices. We have all switches, industrial switches, what you need to control your networks. But also we have on the right side the Fox 615 and the XM320, same product, different segments. One is for power grid, one is for rail, air traffic management, oil and gas. So we are not only in the power grid market with such devices, with such communication devices, we're also in other segments where you need very, very robust and specialized OT equipment for communication. Today we are focusing on the Fox. Fox is a multiplex system for WAN communication, and you see we have an installed base of roughly 40,000 and more. And if you combine this with the withdrawn product, we have an installed base about roughly 200,000. So it's very critical to keep care on such system. Next slide. So what do the below projects have in common? Yeah, with this critical communication device, we control the communication of, for example, the Ariane space, the Gotthard base tunnel, or the safety or the signaling is done in such environments. Of course, the grid communication. Here's an example: the National Grid UK as customer, and also the safety for oil pipelines and control the oil pipelines, the valves, is done with such mission critical application, with such mission critical solutions. Next. And of course, of the growing threat to the critical infrastructure, you see these are numbers from 2014, and I think 6 years we have even much more bigger risk for the critical infrastructure. And on the path from legacy technology to new technologies, for us it's new technology, like on the way from traditional legacy technology like TDM to the packet world, because we have a more interconnected system. Digitalization is coming into our business. We also have a bigger threat about cybersecurity, yeah, about the impact of classical IT vulnerabilities to our system. And these systems are not anymore closed. These systems are connected to a larger network, and we need to keep a special eye on protection on such infrastructure. Next slide. And if you see the requirements on such mission critical networks, if you compare it to an IT network, this is the OT mission critical part. the deterministic scalable real-time requirements we have. The uptime, of course, zero successful attacks, because an attack on such a power grid network or rail network or air traffic network could start human life on risk. Then the lifetime, 25 years, it's the biggest threat we have is that our solution has to be in place for such a long time, and we need a cybersecurity solution what fits inside such a long life cycle. And of course, we also need a solution for the environmental robustness. So a cybersecurity solution what fits into our overall requirements on mission critical networks. Good enough is inadequate for protection of high performance and mission critical data. Because you will never get into a plane if the pilot said, I made a good enough check today. So, and we decided that we need to build a cybersecurity solution for the WAN communication, what fits not only for the next 15 to 25 years. We need to protect and update our system in a totally opposite of IT. So we need a high protection, we need a future-proof system, and from these basic requirements, we started to develop a solution with ID Quantique. Next slide. So this was the birth of the encryption solution for critical networks, the SENC1. Here we try to find a partner with experience with such technology, who is a market leader, and also because we were focusing on our OT know-how and our application, what we are the specialized, and we search for a partner who are focused on such quantum technology and such security technologies. Next slide. And of course, the overall threat, or cyber threat, was underlined from the governments. Yeah, the risk for a quantum threat is not only from the marketing perspective, it's also coming now from the standardization and from the governments, who are more and more pushing such technology. And this means for us, our customers are very, very close to standardization and under the focus of the government regulation, because in most cases, mission critical is the nerves from the overall system. Yeah? Because nothing happens anymore if you have a blackout. Yeah? So, next slide. So the quantum safe activities, what out of the standardization is, for example, the NIST, and we as Hitachi-ABB are also have to follow, because our customer have to follow such initiatives and standards, and so we need to adapt our products as soon as possible to such new upcoming standards. You see, the NIST post-quantum standard is 2024 in place, maybe 1 year later or 1 year before, but for development from our product, it's just a very, very, very short time frame. And on the right side, you see IEC 62351-9 or -4. These are standards for smart grid cybersecurity, and although they are working on post-quantum standardization. Next slide. And this means from a product development life cycle, if we have today 2020 and the standards will come in 2024, and from then we need to, the implementation of the algorithm, we need to start now, because 2 years for development products, for testing, even if we implement the ciphers now, we need a very, very careful test cycle. This needs a long time. So, and if you compare to the lifetime, 10 to 25 years of our products, we need to start now to think about such technology, to implement such technology. For example, for post-quantum algorithms, we already implemented as a proof of concept, in some cases, a dual or hybrid system that we later can, for example, if the post-quantum cipher will be changed in 2024, the recommendation for the NIST, for example, we can also change the cipher then. For that, it is very important to have a solution what are able to change the algorithm, the cipher suites forever. The crypto agility is here. Buzzword. Next slide. Quantum safe digital substation communication. This is one use case where we have now already a product in place. We already have reference customer for that. This was the biggest risk for our communication, because here we are leaving the safe environment of a substation. A substation is where you distribute the high voltage to bring it down, and transformers, and then distribute to, for example, in the city or to the houses. And the typical substation, there's a building with the control systems inside, and the WAN communication to interconnect all the substations from 20 to 100 to 200 or even more substations are connected with the Fox 615, what I showed before, one of our multiplex systems, and protected for all cybersecurity man-in-the-middle attacks with the quantum safe solution Zenq1. Next slide. This is the development what we did together with ID Quantique. So ABB, Hitachi-ABB, Power Grid developed the hardware, and ID Quantique was the specialist for the quantum safe solution, so the quantum random number generator, what we're using on this device. You see, this is a very, very powerful 8 times 10G wired speed encryption, even fanless, and it's all fits in our requirements for mission critical use cases, so humidity, temperature range, shock proof. But what is also important, that this card has their own quantum random number generator for the session keys, for the encryption between 2 devices. But also this device is integrated in an existing system, and you can use it, we say deploy and forget, because it needs some effort to install, but after the device is installed, it is integrated in the system, and you don't need to reconfigure if you reconfigure, for example, the services. And all the services what is leaving the substation, all the WAN ports are encrypted here. Next slide. We gave a special focus on the random numbers. Yeah, as I said, we use the quantum random number generator because we also see that the quantum random number generator is very vulnerable against a lot of attacks. And we decided we don't want to change every time a new vulnerability against the pseudo-random number generator appears, the software. For that, we decided to go with a hardware-based, and we want to have a hardware-based solution, but also able to bring very, very, very strong random numbers as entropy for the encryption keys. Here we decided to go with a physical solution based on quantum. Next slide. You see on the right side the basic principle. The basic principle is that such a small device, it's we are 5 by 5 millimeters. What we are using, there's even a smaller one. What you can use, for example, in mobile phones. But from the principle, it's like you have a source with produce single photons. Yeah, it's limited that it used single photons. It's sent to a half transparent mirror, and sometimes the photon is reflected, and sometimes it's past the half transparent mirror. And by physics, then you have a receiver, and the receiver gives you a chain of zeros and ones, and this is your entropy for your entropy of random numbers. What's important is that this device is also automotive certified. Yeah, and the certification for such automotives are even higher for mission critical. And this means they starting to use this also in the automotive industry because they have the same problem. These cars are stayed for the next 10 to 15 or even longer time in the market, and they need a very, very strong source of random numbers for all the encryption, for all the operating system where we need random numbers. Not only for encryption, you need strong random. And you see there was a hack for the Tesla cars, and they couldn't replace or do an update. So they give an update, but they can't replace it, or they have to replace the hardware at all. Next slide. Yeah, this is also our path for quantum safe communication. Is a very strong random number. Yes, we use a very strong random number for the encryption unit. By the way, we also use a strong random number in our wireless product, and the new choppers is also prepared to use the strong random number by request. Crypto agility, because this is very important, and it's not typical in a OT market, yeah, where you have devices who live for the next 15, 20 years, that you are able to update. And if you see other security technologies where they are implemented in the hardware, for example, if you use a standard MACsec solution, what is implemented in the PHY, you need to replace the hardware. So we use in FPGA in the secure one that you can update later whenever you need. And the last step is the quantum key distribution, where you separate the keys, the key distribution from the classical data channel. And we have several projects where we're working on such technology. ID Quantique already presented a reference customer for that. And for us, it's of course very important to also have a solution for such upcoming technology. And the SENC is prepared to connect to a QKD. Next slide. Yeah, one application is interconnection of substation. And substation have the benefit that the distance is close enough also for QKDs. And as I already said, we are now encrypting such network from substation to substation with the SENC1 with high quantum random number generator for the session keys with RES 256 GCM encryption, so state-of-the-art encryption. But on top, you can add a QKD to separate the keys from the data. Next slide. This is how such a network look like. On the left side, you see today we are implemented here an ETSI standard interface to our system, to the SENC and to the FOX. The FOX is a multiplexer, the SENC is an encryption card. The DRAC server is a key management server. You need such device because we have remote substation. There are sometimes several thousand kilometers from the headquarter away, and then you need to drive out. So you need to replace such device there, and then also to replace the master keys, for example. For that, you need a key server. This communication between is also asymmetric. This means asymmetric means more or less under risk if a quantum computer comes. And this is what we also replace with this post-quantum cipher. And for the DRAC server, for the key management server, we also using a USB Quantis device that we also have very, very strong random numbers for the master keys. And on the right side, you see a network, a quantum channel, quantum key channel. The server is 3 devices connected to a classical encryption and communication network with the FOX 615 and the Secure 1. So on the bottom is the data and the encrypted data, and the keys will shared on the quantum level. And next slide. And 2 reference stories where we already have installed the FOX 615 with Secure 1, a fully encrypted network is in Switzerland, Zentralschweizerisches Kraftwerke, Central Swiss Power Grid Operator. It's a network about 60 substations in the middle of Switzerland. And you see it's running 1 and 10G, and it really looks like this network of substation communication. They're all redundant, configured in rings for failover. Next slide. And the second reference is Oman, very important customer for ABB and Hitachi-ABB now. And this was one of the first project for quantum safe communication. It's a MPS-TP network because it's also a security aspect that we need there a very deterministic network, and MPS-TP, the technology for WAN, gives such deterministic behavior. And on top, we encrypt such technology, such MPS-TP networks, wired speed without influencing from the timing. This is also very important to say that we developed a solution with 2 nanoseconds delay variation instead of seconds, milliseconds, what you have in, for example, an IPsec network, but end-to-end. Yeah, so we can encrypt networks with several hundred nodes end-to-end, and not only hop by hop, like, for example, layer 1 encryption, what you need. For example, if a data center connection, you need high throughput, 100G and more, but it's a point-to-point connection. But we need here an end-to-end connection. And on top, we give the opportunity to run such networks with an quantum key channel to connect to a IDQ's QKD system. Next slide. Yeah,
okay, so we wanted to we have sort of a summary slide. So the takeaways are why do we need to change? So if you remember, we talked about mathematics and encryption, and so our belief is that mathematical based encryption and algorithms are breakable, and they will be, vulnerable with time. Also, the increasing power of computing will increase, so the difficulty of decrypting or hacking data will be easier with that increase in computer power, and therefore even if we have encrypted data today, there's a good chance it will be decrypted rather rapidly as computer increase in power and we have the quantum computer coming. So Ruben, you want to take the other part?
Yeah, and how can we change this? Yes, our conclusion is we need a new way of generating keys in a more random way, because we don't want always to fix and run behind mathematic-based random number sources and the problems what they have. And an innovative and future-safe technology for transmitting the keys. Yeah, this is really, I think, the way to go. Of course, in the end, it will be a mix of the technology between post-quantum, QKD over the air, QKD ground to ground, and but we need to have a new solution for transmitting the most weakest part, and this are the keys for the encryption. And of course, yeah, we say research, deploy, learn, repeat, but this is a standard slogan out of
yeah, I guess that's true for everybody.
Okay.
Thank you.
So thank you very much, Olivier and Ruben for the great presentation. So it's time now to move to the Q&A session. We got quite a lot of questions actually, so we might not be able to answer all of them during the webinar, but we will obviously come back to you later on with the answer if not answered right now. So let me start with the first I have here. So probably for you, Olivier and Ruben, what can I do to get ready for the quantum computer? What are the concrete next steps, concretely?
Maybe I'll start. What we think is that, obviously one of the first steps is really to identify which data is most at risk. Where is it? What is the channel it's using? And how can I protect it? And the first step that we, as I mentioned before, advise is to increase the quality of the randomness, and that can be done not only in phones, but when we talk about data centers, it can be done with quantum appliances, which will distribute randomness and entropy to many devices to increase the power or the intrinsic quality of the randomness in the keys. And that's a very easy step. And then obviously on the most critical links, we already have systems that are QKD and that can be deployed over whatever is already existing. We're interfacing with a big number of encryption providers, encryption devices providers, and therefore you don't need to change whatever encrypted links you already have. In most cases, you can just add that layer of security using QKD and using a separate channel to carry the quantum key.
Okay, maybe on your side, Ruben, what your customer can make concretely to embrace this quantum safe path? Well, I think we've lost Ruben.
No, not lost.
Okay.
Push the button. Yes, as I said, our recommended path is it's more on our hand now to implement the right solution with the right ciphers that the customers have when it comes in place, when the regulation comes, everything on hand. But our solution are prepared for that. Yeah, for example, in our reference customer in Switzerland, we implemented the encryption solution, and this encryption solution can easily be upgraded with an QKD system later. And I think this is a recommended path. What we say that we need to follow the regulation, and from our side we need to offer our customer the right solution that he fulfill the requirements and the standards.
Okay. So thank you, Ruven. So let's go to the next question. So I will answer this one. So the question is, will all PQC dismiss? There must be new math problem that quantum computer cannot solve efficiently. So indeed, but basically the increase in computing power with the Moore law is enough to ensure that any computationally based crypto will decrease over time. So it doesn't really matter if it's PQC or current crypto. You choose a set of parameters today which ensure safety, but in 10 or 20 years, the higher computing power will make them unsafe. So this is why you always increase the length of the keys. And this is the way we're dealing with that problem over the past years. This one for you, Ruven, you mentioned in one of your slides, optical ground wire can be used for QKD. So can you explain what ground wire is, please?
Yeah, the ground wire is the inside an high voltage line, the fiber, and this fiber is protected, of course, with the metal shield, yeah, with the blank wired in a high voltage line. Of course, nobody can touch it, yeah, but this optical fiber is used for communication, typically for control data, for time synchronization, the time of day information, teleprotection, and this goes from on the top mostly of a power line from point to point.
Okay, thank you. So let me take 2 or 3 more questions before we wrap up. Here, there's one question, MPLS TP networks from your example, these are IP-based networks. So the Fox 615 are routers or are they fiber switches? Ruben.
Yeah, it is a multiplexer. So we have, you are right, MPLS TP is a substitute of IP MPLS. And its focus of deterministic behavior. It is an additional technology what is really focused on mission critical application. And our solution has a variety of switching and routing solution inside such a multiplexer.
Okay, so maybe one last question. How much effort is it to refit Substation with the QKD solution? Can I always put it on top, or is there a basic infrastructure needed? I guess it's for you, Ruven, again.
Yes. Yeah, this is it's from point to point, from substation to substation, or from, for example, if you want to protect from the bigger substation, the main lines, you can put it on top. You need an own fiber. Yeah, for example, you can use a ground wire, as you also see in the reference from ID Quantique. Then they and Capco, they also use the ground wire for that, and you can install, for example, a QKD. This is a 90-inch device. Of course, it's not ruggedized. You need to run this in a standard server environment, but then you can run it in the same location, connected with an own fiber. So the classical network is separated from the QKD network.
Okay. So maybe the very final one for you both, where can I find more info on the product mentioned in the presentation? And I'm sorry, we won't be able to answer all the questions, but obviously we will come back to you with answers. So thank you, by the way, for having posted all these very interesting questions, but we are a bit short of time. So this very last one, where can I find info on both products line, on both company website, I guess?
Yeah, just on IDQ side, obviously, there's a lot of information on the website. There's a lot of downloaded PDFs and presentations, and there's also, as Gilles mentioned, this is being recorded, so there is a number of webinars as well that go in some of those products in more detail as well. And you can always email us. I think the emails were shared, and obviously we can try to respond to your questions as well.
Yes, and the Hitachi, you can also find information in the website Hitachi-ABB-powergrids.com. And under communication, you find the products, but also please write me an email and I can send you a link or whatever you want.
Okay, thank you. So again, a big thank you to our presenters and also for all the questions. We will come back to you very shortly with remaining answers. So maybe some high-level takeaway. So what we have seen today. So the risk on cybersecurity caused by the quantum computer, but not only, obviously, is real. And when it comes to the quantum computer, it's just a question of time. Remember this Mosca theorem. So the future of critical infrastructure security lies in the implementation of new technologies, typically those presented by Ruven and Olivier, new crypto tools. And it's really the case that you need to encrypt data against more sophisticated hacking techniques, typically those that the quantum computer will bring in the future. So implementing quantum safe security solutions will allow your organization to encrypt critical data to an unparalleled level, and this will not only protect data for real-time hacking, but also from a download now, decrypt later approach, where criminals or states steal and store encrypted information to decipher them in the future. Quantum key distribution from IDQ combined with state-of-the-art encryption from Hitachi-ABB can and should be used today to improve security on critical links requiring more robust security. And there is no associated risk when implementing QKD. It only adds one but very different layer of security to your critical infrastructure. And soon enough, all organizations will have no choice but to acknowledge the threat posed by new and innovative hacking techniques and move to a better security of their sensitive data, or they risk to be having their data stolen and exploited with major disaster as a result. So the clock is ticking, and it's time for you to start your own journey to quantum safe. And with that, we have reached the end of this webinar. Just before we conclude, we would like to ask you to answer 2 quick questions, so please take some time to answer them. Thank you. Okay, if I quickly look here, it's pretty spread out, all the answers, but most of you still don't know, let's say close to 50%, and the other half see something in the next 12 months, if not 6 months. Okay, thank you for that. Let's move to the second question. So that's the usual question for all webinars. So thank you for your feedback. So on behalf of IDQ and Hitachi-ABB Power Grids, we would like to thank you very much for your time today. We hope the session and the content have been informative and beneficial, and will also help you to define and better frame your security strategy for the coming years. So we wish you a great evening, and don't forget to keep on keeping social distancing. Thank you. Bye-bye.
Thank you, Jill. Bye-bye. Thank you, everyone.
Bye.
Bye-bye.